So the next thing we have to deal with is how do you solve a problem like this? What if you can't get a common base? So there's no way I can change either one of these to create a common base. So that's when we have to understand the idea of logarithms. And a logarithm is just an inverse, the inverse function, inverse operation of exponential. So just like squaring and square roots are inverse functions, multiplying and dividing are inverse functions, exponentiating and taking a logarithm are inverse functions. So one of the things that can really help you is if you remember, and actually I use this very first one right here, log base 2 of 8 equals 3 since 2 to the third power equals 8. And if you remember this right here, you just kind of remember this relationship, have that memorized, that will help you when you are trying to rewrite any log expressions. If you're trying to rewrite it as an exponential, you'll be able to do that if you keep this in mind. So we're trying to evaluate log base 3 of 81. So in order to do that, we want to try and come up with that value. If you want to, you can actually say equals x and then solve for x. So what we're trying to do then is we're going to say 3, because 3 is the base. This is, by the way, you would read log base 3 of 81. So 3 is the base. You're going to make x be the power, and we want 8 to get an 81. So 3 raised to what power is 81? Well, now you could solve this by getting a common base. So 3 to the x power, 81 is 9 times 9, and 9 is 3 times 3. So this is 3 to the fourth power. So we get x would be 4. So this whole thing equals 4. Okay, so on this next one, I'm going to think about 5 raised to what power, and I just use an x to represent the what power, equals 1/25. So I'm going to find a common base, which is 5. So this is going to be 5 to the negative 2. So then x would have to equal negative 2. So that would be what this expression is. This next one, and again, I'm saying it, but let me just make sure I point this out to you. Think about this as 4 raised to what power is 32. So if you think about it that way, that will help you rewrite it. So 4 raised to what power is 32. And then do the strategy we just did, common base. So we're going to have 2 to the 2x equals 2 to the fifth. So we get 2x equals 5, or x equals 5/2. Okay, next problem. 8 raised to what power? Now let's think about how we were supposed to rewrite this. Remember, this is 2, it's a square root, so it's 2 to the 1/2 power. So we have 8 raised to what power equals 2 to the 1/2 power. So I'm going to find a common base, which would be 2. So I'm going to think of this as 2 cubed, so I'll have 2 to the 3x equals 2 to the 1/2. So 3x equals 1/2. Divide both sides by 3, and you get x equals 1/6. So on the next one, I'm going to think of this cube root of 5 as 5 to the 1/3 power. So I have 25 raised to what power equals 5 to the 1/3 power. So my common base is 5, so I'm going to have 5 squared, or 5 to the 2x, equals 5 to the 1/3. Now I have common bases, so that means that 2x would have to equal 1/3. And I divide both sides by 2. And once again, I get x equals 1/6. On the next problem, I'm going to think of this as 6 to the 1/2 power, except it's in the denominator, which means that it's a negative exponent because it's flipped over. So it's going to be 6 instead of to the 1/2 power, it's going to be to the negative 1/2 power because it's a square root, which means You have a rational exponent with a 2 in the denominator, and because it was the reciprocal, you have a negative exponent. So I'm going to have 36, because that's the log base, so 36 raised to what power equals 6 to the negative 1/2 power. So my common base is 6, so this is 6 squared, so I'll have 6 to the 2x equals 6 to the negative 1/2. So I get 2x equals negative 1/2. And if I divide by 2, I get x equals negative 1/4. On the next one, 9 is my base, so 9 raised to what power equals 1. Now, hopefully you just know the answer, because in order to get a 1, it's going to have to be the 0 power. But remember what we did on that last problem. We said we could create the same base, and we can write this as, this would be 9 to the 0 power. So we get x equals 0. So that is how you can rewrite a log statement. And the strategy to doing that is in your mind, or you can just say it out loud if you want to, or just think of it as, like I did on this one, log base 4 of 32. 4 raised to what power is 32? So that's the strategy you would want to use for those. Okay, so we have a few more, and we're going to use the same idea. So the log base is 9, so 9 raised to what power is 0. Now on this one, think about an exponential function. Think about the graphs we did when we had, think about if you had y equals 9 raised to the x power. And if you graphed that, you'd have some kind of a shape that looks like this. And the question is, when is that 0? Never. So there'd be no solution to this one. Okay? Next, 3 raised to what power is negative 9? Well, just like I talked about up here, this is saying 3 raised to what power is going to give you a negative. Well, take a look here. It's always positive, always positive. So this is no solution. And actually, this is something that we can learn that now about taking a logarithm for any log base. If you have y equals log base b of x, the domain of a log function is, for this, would be x is greater than 0. It can't be 0 and it can't be negative. So these two would produce no solution. Okay, on the next one, think of this as 5 times log base 4 of 8. So we're going to multiply our answer by 5, whatever we get to this. So I'm going to start with 4 raised to what power is 8. Common base is 2, so we get 2 to the 2x equals 2 cubed. So I get 2x equals 3, and x equals 3/2. But I have to multiply by 5, so I get 5 times 3/2. So we end up with an answer of 15/2. So if you have an extra operation to do, that's fine. You can just do that at the end. I'm going to do the same thing here. First, I'm going to evaluate inside the parentheses. I have 9 raised to what power equals 1/3. My common base is 3, so this is 3 squared, so 3 to the 2x equals reciprocal, so I'm going to have 3 to the negative 1. So I get 2x equals negative 1, and x equals negative 1/2. But it was squared, so my answer is negative 1/2 quantity squared, which is a positive 1/4.